AP statisticians. I hope you guys are having a great day. Today we're going to do 3.2.1 in the practice of statistics, which is just kind of an introduction into the least squares regression line and what least squares regression is. The next lesson we're going to be getting a little more in detail and into like what that actually means. But anyways, so today our goal is to be able to interpret the slope and y-intercept of a least squares regression line in context. So remember, again, in stats, everything is about context. It's super important that you always include context. If the question asks about crying babies, then your answer needs to have crying babies in it. Okay, context is super important. You should also be able to use least squares regression line to predict y for a given x, and then explain the dangers of extrapolation and what extrapolation is. Okay, so let's start. Least squares regression line. Okay, this is formerly known as, probably if you ever took any class with me or ever took like algebra where they talked a little bit about scatterplots. It is also known as the line of best fit, but in stats, it is more formally known as the least squares regression line because of how it's actually calculated. So basically, least squares regression line, right now, before I get into depth, is basically just a line that describes how a response variable, okay, remember response is on the y-axis, how a response variable of y changes with respect to x, or the explanatory variable. Okay, so the equation of the line of best fit is, well, it's a line, so it's kind of like y equals mx plus b, but in stats we use a instead. I'll show you why it just correlates to the calculator a little bit better. Y equals ax plus b. But the important thing is, since it is a prediction, it's not the true line for the data, you need to indicate that somehow. And so what we do when we create our equation is we make it a y hat equals ax plus b. Okay. Now, depending on what you use your calculator, what you use in your calculator, it could be y hat equals a plus bx. Just, you know, the slope is the number that's in front of x, and the y-intercept is the constant, and vice versa. The number in front of x, right? Okay, so hopefully that makes sense. You have enough common sense to figure that one out. Okay, anyways. So, the hat means that y is actually a prediction based on an x value. So if you don't use the hat, you will lose points on my test and potentially on the AP exam as well, because it means that you don't understand that the least squares regression line is actually just a prediction. It's not an actual value. And then you always have to, when you're writing out the line of best fit, you always have to include the context. So say, for example, my x variable is age, for whatever reason. And y hat is like number of children or something. I don't know. X, so when you're just describing the equation, you need to have where x is age in years or whatever, and y hat is the predicted or estimated number of children. Okay, something like that. Or the other option is to literally just write in, instead of y and instead of x, just type in number of kids, hat, and then age here. Okay, so whatever way you do it, but you need to include context in the formula. Okay? Okay, interpreting slope and y-intercept in context. So this is super important, again, because context is really important in stats. Don't forget it! Okay, so interpreting the slope in context. So remember my horrible example where I was looking at age and number of kids. So say maybe we surveyed several middle-aged women and figured out, how many kids they had, and just graphed their age with their number of kids. So your line of best fit is the line that fits the data the best, right? Or least squares regression line. So I've kind of sketched in a line of best fit there and a example scatter plot. It's not great, I'm sorry, but it'll get my point across. So the slope, right? Say for example we come out and it turns out that our line of best fit is y equals 3x minus 2. Okay, it's not going to be that because with real data the numbers are nasty, but again, to make my point. So interpreting the slope in context, you need to know, what is the slope really? Okay, so in this case, the slope is 3 over 1, right? And remember, slope is rise over run. And so, if my rise is the number of kids, then my run is the increase in age. Okay, so the way I would interpret the slope is that for every 1 year, this obviously is not an accurate portrayal of a real life situation just because I'm making up numbers. But as a woman's age increases by 1 year, we expect the number of kids that she has to increase by 3. Now, keep in mind that I have used the word expect, or we predict to, blah, blah, right? So you need to use the term prediction or expect or, estimate or something to indicate that it's a prediction, not an exact value. So I'm going to write that out. Okay, so given my example of my numbers, this doesn't actually make sense, but you get the idea. Okay, so same thing with the Y-intercept. So you might also need to interpret what the Y-intercept is. And in this case, my Y-intercept is -2 from the problem that I gave you. And basically all that means is that, if the x value is 0, then the y value would be -2. And in the case of age and kids, right, if the x value is 0, that would mean that the age of the mother is 0 and the number of kids is -2. So this doesn't make sense, right? But it is still the interpretation of what the y-intercept actually is. So I'm going to write it down. Note that it doesn't make sense with the problem. And we will talk about that in just a second. Okay, extrapolation kind of addresses that issue. So extrapolation is basically predicting a response variable for something that's way far outside, or not way far out, but significantly outside the range of x values that you have. So, if all of my data, right, in this, say I have a graph and all my data is from, 10 to 20 or whatever, if I try to predict something that's outside of that x value, so between 0 and 10 or 20 to infinity, if I try to use my least squares regression line to predict a y, often it won't make sense because you only have data for a certain range of x values, and so predicting outside of that range typically will give you bad information. And so in the case of the mother having -2 children, right, the y-intercept in that case was actually extrapolation because it doesn't make any sense with the context of the problem, and our data was not within the range of 0 to 20 or whatever. The age of the mother, we weren't even studying mothers who were age 0. So that would be extrapolation. Okay, so there it is written down for you. Okay, 2 quick reminders, AP exam and my test tips. Common errors are people mixing up y hat and y. Y hat is the predicted y is the actual y. So don't mix those two up. And the other thing is don't forget to include context and what variables actually are representing. So if you use y hat equals mx plus b, say, hey, where x is blank and y hat is the predicted blank, just so that you have the context in your answer. Okay, in your calculator, after you have created a scatter plot, where you put stat, edit, and you enter your data in your two lists. So for me, for example, I'm doing L2 and L3 as my scatter plot. First, you have to make the scatter plot so it knows that it's trying to compare those two variables. So I would tell it, okay, I want you to plot list 2 versus list 3. I believe it should be perfect. But anyways, so zoom stat, zoom 9. So again, your calculator knows that you're comparing those two. It's typically a good thing to do. Right? It's not absolutely necessary in this case, but you need it for other things later, so you might as well do it. Go into stat, calc, and then see this lin reg here, lin reg ax plus b. That is what you want for your regression line. You need to tell it, okay, I want you to do list 2 versus list 3. Store regression equations, so that's if you want the calculator to store the line of best fit into y equals, into like y1 so that it plots it on the graph. So to do that, you can hit vars, which is variables, and then y variables, function, and then just click y1 and calculate. Okay. And then it tells you what your line of best fit is. So y equals ax plus b, where a is 0.079487, b is negative 6.5897, and then your r value, your correlation coefficient. And so just as a refresher, I stored it in y1, so if I go into y equals, my line of best fit is there, and so when I hit graph, it actually graphs the line now. So that's an option that you can do as well. Okay, so if you need it written down, stat, calc, lin reg, ax plus b after your data is in the lists. And then for the y variable, you want to go to vars, y vars, function, and then click whatever y you want. I'll write that down. Okay, lastly is predicting y hat with a least squares regression line for a given x value. So given our really bad example earlier of the women's age and the number of babies, how many babies do you predict a woman 30 years old to have? Remember, x is the age, y hat is the predicted number of kids. So you would just plug in 30 for x, multiply, then plug it in and find your predicted y. So you would end up getting y hat to be 3 times 30, which is 90 minus 2, which is 88. 88 kids. My example sucks, but that would be how you did it. What the heck does least squares regression or least squares part of that term? What does that mean? We're going to actually talk about that in class, so make sure you ask me. We're going to discuss it a little bit further in depth. So check in on that. So go ahead, try the next 2 examples. So you've got this example, does fidgeting keep you slim? So you can actually plug the data into your calculator and then find what the typical, what your least squares regression and your correlation coefficient are. And then also this one. And then I'm going to do the answers. I'm going to write them out because I don't have a lot of time to explain them. So let me know in class if you have questions. So this is my scatter plot for the first one. It does seem, so my x-axis is the NEA change, and my y-axis is fat gain. So it does seem that as you increase in NEA change, you decrease fat gain, and your R value will be negative for this as well, so that would be another indication. So, good deal. Okay, here are the answers to the rat questions. So hopefully you got those. It's not too bad. See you in class. Bye!